Hi, and welcome to today's lesson, which is the 5 main factors that constitute climate. So we'll be looking at the 5 factors that, when together, form what you would understand as a typical climate. These 5 factors are altitude, latitude, topography, oceans and large lakes, and Earth's wind. Let's start with altitude. Simply put, altitude means height. Anytime you're in an aeroplane, you'll often hear altitude being described. So when we're at this situation, we can see that the plane is at mid-altitude. But as it starts to increase and starts to climb more into the atmosphere, it will be at a higher altitude. So altitude simply means height. But how does altitude affect climate? Well, if you had a mountain and you started walking up, you'll find that the temperature will drop around 6.5 degrees Celsius for every 1,000 meters climb. So we can understand that altitude has a direct correlation with cold. This has meant that you can look at a mountain and simply based on its elevation, how tall it is, you'll be able to somewhat accurately predict the temperature. If 1,000 meters is 6.5 degrees Celsius minus, you can then look at a 2,000 meter tall mountain and you can predict the temperature based on that simple equation. So the higher the altitude, the colder the climate. And that's the first one. Where you are will have different climates purely based on how high above sea level you are. The next one is latitude. So latitude, you typically hear this latitude and longitude. So we'll just be looking at latitude. Latitude has 2 definitions. The first one, more technical, is the coordinates used to specify north and south positions. And the simpler version is just the sideways lines on a globe or a map. So here we can see the latitude lines. We can understand that it is the sideways lines on the map, but it also tells you how far north and how far south you are. If you were in Sweden, for instance, you would be far north in latitude, but if you were to go to South Africa, you would be more south in the latitude line. But how does latitude affect climate? Well, the Earth gets a lot of its energy from the sun. But how much it receives largely depends on just how close you are. In this situation, we can see that the center part, that receives the most, and we understand that as the equator. So the equator, being the center line of the Earth, will receive the most brunt of that energy. So the angle of sunlight is really focused in the middle, but the more north and south you go, there's less sunlight because the angle becomes tighter. If you see the top line, you'll notice that the exposure is quite an acute angle, and this has a big impact in terms of how it affects how much exposure to heat you get. Take a heat pump, for instance, very common in New Zealand. If you stand right underneath the heat pump, you'll find that you get the biggest and greatest exposure to that heat, so you benefit the most. So your situation is much different. You got more warmer, you probably wouldn't need your coat, your needs would be different. But if you were very far away, you would have a completely different situation. Now this is exactly the same situation with latitude. If we were to turn this 90 degrees, we'll find that just as a heat pump will give more benefit and more heat to someone right directly underneath it, giving them more access to that heat, and somebody further away won't get access to it. Same thing works. When the angle of heat is strong and direct, you get the most impact. As you go up all the way to the very top where it says the angle of heat is cold and distant, you'll reach a point where you're so far away and so inaccessible to that direct source of heat that it barely has the desired effect, that being keeping you warm. Now this is basically the same that happens with the planet. The planet will have sunlight shooting at the closest source, that being the equator, and then everywhere far away, versus the North and South Pole, they'll be so cold purely because their angle is so sharp, north and south, that they virtually get no sunlight. If you were to imagine a basketball spinning on a finger, and you were to get a torch, you can see how in this situation, it's getting an even consumption of light. As the ball begins to rotate and orbit, it's exactly the same force all round. If, however, we were to change the angle of the Earth, now we understand the Earth is at a 23.5 degree angle, now you'll notice that some parts won't get that full exposure. And that's sort of what happens as well. In Burroughs, Alaska, one of the most famous examples of this, the sun rises for the first time in 2 months. Reading this article, you'll hear strange things that they welcomed a long-lost guest, a sunrise. But the sun showed up over Burrow Wednesday at 1:28 p.m. and stuck around for 23 whole minutes before dipping below the horizon again. So imagine if the sunlight in your area only came up for 23 minutes. According to Alaska's website, the farther you travel towards the North Pole, the longer the days are in summer and the shorter they are in winter. During the summer months, Alaska enjoys extended daylight hours in all parts of the state. In Burrow, the sun doesn't set for 84 days. It has to do with the Earth's tilt in relation to its orbit around the sun as the seasons change, the website explains. So this is essentially a really great example of how latitude will impact climate. So in this situation, we can see that the top grey triangle is a blind spot. That's around where Burroughs, Alaska lies. So that's their latitude. That's why they have that situation with the sunset and the sun rising. If the sun was to change, so obviously the sun wouldn't be moving, we'd be moving around it. It's only after a couple of months, so in this sense 84 days, so 2 months, for us to see the sunrise. It's essentially largely again to do with the fact that the orbit and the tilt of the Earth, that's what results in this effect. If you're so far north, you'll be in a blind spot that you won't see the sun for a long time. And it'll be a couple of months before the whole planet moves in its orbital track before you can see the sunrise. So latitude has a big impact in terms of how you experience climate. The North and South Pole, for instance, are very, very cold, largely for this reason. They're in this blind spot, so their angle is so tight up north that they experience virtually no exposure to the sun on the north and the south. Now, another layer of importance regarding latitude is that it controls seasons. And it all largely has to do, again, with what we mentioned earlier, that the Earth is at roughly a 23.5 degree tilt. Now what this does is it controls and contributes a huge part of our climates and seasons. Due largely to this tilt, in July we'll find that the northern hemisphere experiences summer and the southern hemisphere experiences winter. So the planet tilts, so in July the top portion, the northern hemisphere, is leaning towards the sun. And that leaning means that they get the most concentrated sunlight. The winter portion, which is the southern hemisphere, it leans away. So by leaning away, they don't get that same brunt of force, so it makes a huge impact in the climate, so we understand those as seasons. So in July, if you're in England, for instance, you'll experience summer. If you're in Australia, you'll experience winter. If you fast forward 6 months, you'll find the exact opposite is true. Now in January, the southern hemisphere experiences summer because it leans towards the sun, and the northern hemisphere experiences winter because it's leaning away from the sun. Largely what we'll notice is that the concentrated sunlight in July will focus on the Tropic of Cancer, and 6 months later, you'll find that it will focus on the Tropic of Capricorn. What's interesting is that this same pattern will repeat in September and March, but instead of one of the tropics, it will focus on the equator. So that would indicate that at some point throughout the year, either the Tropic of Cancer, the equator, or the Tropic of Capricorn will receive the focus of the sun's energy. Meaning that this area, this slice shown on in this globe here, will always receive a lot of energy from the sun, which is known as a tropical zone, so it's called the tropics. And that area receives so much direct sunlight that it's known to be very, very hot. So what this does is it can affect your climate in a variety of different ways. And that is latitude. So far we've looked at altitude, that being the higher altitude, the colder the climate, and latitude, the more north and more south you go, the more exposure to the sunlight. Next, we're going to be focusing on topography. So topography is a very interesting factor. Topography is defined as the physical and artificial characteristics of an area. Simply put, it's the surface features. So this is an example of topography. You've seen many maps like this before, and this will indicate the elevation, how steep a hill is, any valleys there, and all of these examples are topography, the features on the Earth. Here's a very cool one that shows mountains in a very nice line diagram. Here we have another one, more 3D rendered. You can find something very similar to this in Google Earth. Now, when we talk about topography, mountain ranges are going to be our focus because it's an excellent example of how a topographical feature can play a major role in a climate's precipitation or rain levels. So it's kind of strange to think that mountains will affect how much rain you can get. What will happen is that humid air moves in from the ocean. So you've got all this moisture in the air, and that air is being pushed over the oceans and it's headed towards the mountains. It rides up the mountain slope, it actually climbs the mountain. So you've got this humid air, it goes over the water, hits the mountain and starts to climb the mountain. Now we understand from the first factor, that being altitude, the higher you go, the colder you get. So what will happen is, as the air begins to go up in altitude, it cools down and the vapor begins to form into a cloud. And what happens is, as all this air starts to go up and up the mountain and starts to get colder and colder, it will begin to form a cloud. Now, this cloud is made up of water. Inside, it's lots and lots of little water droplets. Now, they will begin to collect in a mass. So you can slowly see how these tiny little water droplets will begin to form, and they can suspend in the air. But then they begin to get heavier and heavier until they form one big drop that can no longer be lifted up, and once it reaches that point, the dew point where it can no longer hold its own weight, it falls. Now that creates an interesting phenomenon, but the simple idea is air comes up from the ocean, it's got a lot of humidity in it, it starts to rain from the ocean side. The flip side is that now that all that moisture's gone up and you're at the peak of the mountain, it continues down. So it's climbed up and now it begins to climb down. As it starts to climb down, it becomes warmer, because remember the opposite of altitude would that be the case. So if altitude, the higher you go, the colder you go, well, the lower you go, the warmer you go. So as the clouds begin to go down the mountain, they'll begin to get much more warmer and they'll start to disappear and dissolve. And for this reason, the side of mountains that face away from oceans are typically dry. And we're going to look at 3 examples here. This is Nepal, so this is where Mount Everest is. See where the water is at the south, and you'll notice that one side is very green and one side is very dry. That humid air, carrying water from the Indian Ocean, is going to be going over the ground. As it climbs up the mountain, it condenses and rains, so then a lot of trees can grow. It's very green. But then on the other side, it begins to go down the mountain, and from that point, it starts to go drier, and then that's why you get this situation where one side is green, one side is dry. Christchurch, New Zealand is another example. You'll notice that on the side of the mountains close to the water, it's all green and lush in vegetation. As the water climbs down, it becomes quite dry, and that creates that situation where the mountains in the middle, it's green on one side, dry on the other. Lastly, we're going to see the Nevada desert, one of the most famous deserts because that's where Las Vegas is. You'll notice in America, you have the area, California on one side, right next to the ocean, all that moist air coming along. It climbs up the mountain, so you've got a lot of green vegetation, and then as it climbs down, it becomes dry. So this is that same situation. And this is called a rain shadow. So a rain shadow is where rain is formed simply because the humid air will climb up a mountain, get condensed because of the first factor, that being altitude, and then as it goes down, it will lose that cold and then become more warmer and then just dissipate into nothing. So that is topography. So the first 3 we have is we've got number 1, that being altitude, the higher you go, the colder you go. Number 2, latitude, which is the more north or south you go, the more exposure to the sunlight, the more heat you're exposed to. And finally, topography. So how can mountains affect how much rain you get? The next one we're going to look at is oceans and large lakes. This is an interesting one because it seems to contradict everything we've covered so far. You can see in this map that San Francisco and St. Louis have the same exact latitude. They're on the same line. Now, what would that tell you? Well, simply put, it would tell you that they must get the same amount of sunlight. So they should have very similar climates, right? Well, it's actually very different. In San Francisco, the summer is quite mild, so it's quite tolerable. And the winter is cool. It's not too blistering. It's not like in some places, like in Canada, for instance, where they reach negative 26 degrees Celsius and it's inhospitable. The winter is manageable. On the flip side, St. Louis, their climate is very, very different. Their summers are blistering hot, and their winters are unforgiving. Now that's a little strange. They get the same amount of sunlight. So how can their climates be so different? Well, the difference is actually quite interesting in this situation. Do you remember when we looked at the heat pump and we saw that the closer you are to the heat pump, the more effect you get? If we were to scrap that heat pump and just put an ice block, that would mean that that guy closer to the ice block is more affected and more cool because he's closer to that source of cool. And the guy far away from it is going to be unaffected by this ice block. This is quite similar to what happens in San Francisco. The air pushes the ocean breeze over San Francisco as a giant air conditioner. So we have that nice cool breeze coming from the ocean, and it pushes and it cools down San Francisco like an air conditioner because it's right next to the water. The problem is St. Louis is very far away from that breeze. So it goes the ocean, a nice cool effect, it carries it and pushes it, and it calms down San Francisco's climate. But that same effect can't be carried for that long. By the time it reaches St. Louis, it no longer carries that effect. A similar example to this, if you can visualize it, would be a computer. How does a computer fan cool down? It simply takes some air from outside and it just pushes it all over the motherboard, it pushes over the graphics card, and then it cools it down that way. If you were to have a fan at one end of the computer and what you're trying to heat, or we're trying to cool down, at the far end, it would lose its effect. So they put the fan right next to it. They put a lot of vents there because they want it to be close. So even in a small scale, like a computer, this effect can be seen. You want to put something that you want cooled down, you put it right next to the fan, not far away from it because it will lose that impact. So oceans and large lakes acts like a giant natural air conditioning system, which is quite cool. So now we know that where you are, if it's close to a massive ocean, if it's close to a large lake, it will have a really nice air conditioning effect. And that is the oceans and large lakes. So number one, we've seen that the higher up you go, the colder you go. Number two, the more north and south you go, the more exposure to sunlight. 3, your landforms nearby, they can affect how much rain you get. 4 is oceans and large lakes can impact your climates by simply cooling down, by carrying that cooling force and applying it to you. The last one we're going to look at is Earth's winds. So Earth's winds is actually a very, very important one. There are 6 belts of wind that encircle the Earth. These are called prevailing winds. They push along warm and cold air masses, moisture, storms, and pollution. So they all will move and they'll circulate all that warm and cold air all around the globe. Now, where these prevailing winds meet, we'll call those trade winds. So the trade winds play an important part. Now, the equator, remember, it gets the most amount of sunlight, typically throughout a year. That heat will heat the ground, and what happens to hot things? Well, hot things rise. So that tells the air to rise. So if you imagine the equator, it has both sides, both of the trade winds, as they come together, they're both telling the air along the equator to rise. And that, if we remember the altitude, the first factor, is going to cause anything in the middle in terms of air to rise in altitude. So what will begin to happen is that all that moisture will begin to collect and go higher and higher and higher, and as it increases in altitude, it will start to condense and those water droplets will begin to collect and become heavier and heavier until it starts to rain. Now this area we understand as a doldrum, that's the name given to it. And you can see from the previous picture, the doldrum, look at this circle around the equator. It's like a belt of clouds, and that's largely caused by this effect. Every time the sun hits the equator, heats the ground up, the ground tells the air to go up. As it goes up, starts to condense and it rains a lot. Here we can see two effects, how it can cause a dry area on the right and a wet area on the left because of a combination of rising and sinking air. To illustrate just how significant Earth's winds are in constituting climate, if the equator gets the most amount of sunlight, that will tell the Earth, as we understood, to heat up. So the air goes higher and then it starts to condense because of altitude. It will then cool down and sink, because if hot air rises, cold air sinks, but it will sink 30 degrees north or 30 degrees south. Now that does a very significant impact on the climates of areas in these regions. If you live 30 degrees north or 30 degrees south, anytime your clouds try to form, the air from the equator is sinking and keeping them down. So most of the world deserts are found around 30 degrees north and 30 degrees south of the equator, because that sinking air prevents those clouds from forming. It produces what we understand as a high pressure sky. And clouds can't form in high pressure skies. They need low pressure skies. Looking at this map, you can see how the distribution of hot desert climate zones are largely concentrated 30 degrees north and 30 degrees south. And this is largely due to that effect. The equator receives a lot of that force from the sun, and then it heats up, so it condenses, and then as it sinks 30 degrees north and 30 degrees south, creating deserts in the north and the south around 30 degrees. And those are the 5 factors that constitute climate. 1, altitude, higher you go, colder you go. 2, latitude, the more north, the more south you go, the more exposure to sunlight. 3, topography, that being landforms can impact how much rain you get. 4, oceans and large lakes. Having large bodies of water will create a cooling effect. And finally, Earth's wind. 5, Earth's wind, this will move around hot and cold air and creating different effects, even the deserts of the Earth. And those are the 5 factors that constitute climate. And that's today's lesson. If you liked it, please subscribe, leave a comment of things you'd like for me to cover, and if you're a teacher and want to get your hands on this PowerPoint, it's available on tests, link in the description.